Hey guys, little bit of an update on my Sprint 2 repair PCB that I did. I got a comment about not being uniform, these dots, and you can see this is, I got my video pulled up on the TV, and you can see you got a fat dot, skinny dot, fat dot, skinny dot all the way through here, right? And that is not correct, because I did pull this up on MAME, and they should all be the same. And if you look up here, you'll see, you see how this is kind of cut, and time is kind of cut on the end. And if we come over to here, see the A on black is kind of cut there, and the B and the O, the 0, should be symmetrical. It's kind of cut straight down. It's like the character ROM is being cut short. You can see it over here too. You got a straight line, straight line, straight line, and then you've got, you know, the fat dot, short dot, and it's cut. Fat dot, short, cut, fat, cut dot. Also, another thing is I could not get the oil slick to reappear. On no matter what I did with the dip switches, the oil slick would not appear on the track. Well, I'm going to take you over and show you this PCB now. And I put it on little TV because it's just a better picture. Little TV through the AV jack. Now you see the dots are all symmetrical and right. And the zeros are symmetrical. And the oil slick's there. Okay. The oil slick thing, the dip switch stuff, I'll show you on the schematic. This guy right here is a 156, and it gets inputs from the addressing, and you can see here through this switch are all of these signals. That chip was bad. I don't have any 156s, but the customer sent me 2 spare boards for parts, so I pulled a 156 out of one of the other boards, and that made the dip switches work properly. So you have your oil slicks. The second problem was this 166, and I pulled and removed these guys right here. These are the bipolar ROMs for the character. Basically, everything that you see besides the cars are motion. That's the motion circuitry. Everything else is derived in this circuitry with these ROMs. And if we look at, and I pulled these 2 guys out and I tested them in my reader, and those were fine. The bipolar ROMs were fine. I tested all the little gate stuff around it. I looked at this 161, all these other little gate chips, and this was the only guy that was left, was this 166. So I jumped a 166 over top of it, and it made no difference. But I was like, sometimes that just doesn't give you any results. So I knew I had to analyze that guy. And I'm going to get some paper out, and I'll show you exactly what this was doing and why it made sense, why we had that cutting off of the dots. You had a fat dot, skinny dot, fat dot, skinny dot. I'll show you exactly what this guy was doing. I did not record analyzing it because my camera was dead. But I'll get a pad of paper out and show you what it was doing. Okay. I'll try to do this. Okay. A 166. has a clear, has a shift, load, okay, has a serial input pin, has a clock inhibit, okay, and that's all of the control. Then it has a 8-bit data input and a 1-bit out, serial out. Right? Is that getting in the frame good? Is that working? Okay, yeah. Okay. So, what was happening? Serial input was tied to ground. All right. This was tied to ground. So you're always going to be inputting a 0, and the clock would never be inhibited. Let's just say for S's and G's that this is always high, tied to 5 volts. So it's never clearing. It's only shifting and loading, right? Okay. So this is what I would see. I would see a load pulse, right? And this whole time, the clock is doing this. Okay. And let's say our data inline was 0, 0. No, let's say it was 0, 1, 1, 0, 0, 0, 0, 0. This is the least significant bit. This is the most significant bit. Okay. And here on my output line, let me make sure this is in the frame again. I don't want to be doing this for nothing. Okay. On my okay. My output line would be 0, right? And then right here, it would load, and I would see this go to 1. Right here, I would see 1. Let's say this was doing this. Now I'd see 1. And I'd see 1 for 2 pulses. So it'd be 1, 1, 1. And on this pulse, it'd go low. Okay, so that's what I was looking at. That's what I was seeing. That's not right. What this should have done, what it should have done, is it should have loaded right here. It should have went like this. Okay, now it loads, so it should stay 0, because when it loads at this rising edge, then this 0 is going to stay here until the first pulse. And then in from this side comes that tied 0. Remember, our serial input is tied low. So you have 0 coming in right here. When it loads this internally, and it latches that in that 166 from least to most significant bit. And with this first clock pulse, once the shift is high, remember you got, this is the shift load line. So when it goes low, that means load. At this pulse, it loads this word into the register. And then with the first clock pulse, it shifts this 0 in here and everything shifts over. And at Q output, you have 0. So this should have, when it loaded, it should have stayed 0. And with the first pulse, okay, at this load, we stay here. At the first pulse, we come over and it stays 0 again. Because now we have 0, 0, 0, 0, 0, 0, 1, 1 internally in that 166. So it stays a 0 here. Okay, with our second pulse, see that's load, and then 1, 2. With our second pulse, once it's shifting, 1, 2, then we get our 1 right here. And it stays 1 for only 2 pulses. So 1, 2, and at the third pulse, it goes low. See, load, shift, shift. Load, shift, shift. And then we're back at 0. So load, 0. Shift, still 0. Because that 0 came out at the output. And then we shift again. Now that 1 goes to the output. And then the second one goes to the output at the second rising edge, right here. And then we have a 0 here, and at our next shift pulse, that 0 comes out, so it goes back to 0. That's what it should have been right here. It was shifted. It was shifted over. It's like this was stuck internally. It was stuck 1. So I was seeing 3 1s. 1, 2, yeah, 1, 2, 3 1s, and then 0. When it should have just been 1, 2, 2 1s. So it was 1 too much. If that makes any sense, I don't know if I'm explaining that very good, but that is what was going on. Instead of, it was loading with a 1 at the output when it should not have been. It should have been loading that, and then it'd take 2 shifts to see a 1 at the output, but it wasn't doing that. That's why you had, when the beam is scanning and it's a 1, it's supposed to be a 0 and it's seeing a 1, then maybe it's making that too fat, right? I don't know exactly how that works, but I can tell that that's why it just wasn't right. It wasn't spaced out enough. It was scrunching that together too much, and it was making them not uniform. That's what I should have saw. This is what was actually happening. So I replaced that 166, and that fixed that problem. If that makes any sense at all. That is going to do it. I just wanted to do a quick little update. Couple problems fixed, and that one is good to go now. See you later, guys. Thanks for calling me out on not having it fixed right, by the way. Appreciate it. We'll see you.